Alright guys, good morning, happy Tuesday. This week we're going to be talking about exponential growth and decay equations. So we just got done talking about exponential functions and logarithms, and those are sort of inverse functions. Those are opposite functions, and we saw that a little bit when we would write equations like log base 7 of, x equals 8. And we'd say, well, I can't really solve that. So let me write that in a different format. Let me write that as 7 to the 8th equals x. So that's kind of how we saw our connection between exponential functions and logs, those inverse operations. Now, this week we're going to talk about exponential functions of the form y equals a times b to the x. And the key feature of that exponential function, what makes it an exponential function, is the fact that I've got an x in the exponent. That's that key feature we're looking for to identify an exponential function. And exponential functions are going to come in two types. They'll either be exponential growth or exponential decay. So, let me change that. Let me make that green for growth and orange for decay. So to identify the difference, we're going to look at the number in the base of the exponent. We're going to look at that b. So, for example here, 4 times 1/2 to the x. 1/2 to the x is that power, and I know it's exponential because x is in the exponent. And we should really be focusing on that number 1/2. So a number smaller than 1 is going to tell me that I've got exponential decay, because it's going to get smaller and smaller over time. Something that decays is losing mass, it's losing matter, and a number bigger than 1 is going to be exponential growth. So 1 is sort of that tipping point, if you will. It's the number that we're kind of measuring everything against. So here are some examples of exponential growth and exponential decay functions. You can see here it doesn't matter how much bigger than 1 this base is going to be. As long as it's just a little bit bigger than 1, that's what counts. And if you're ever unsure, you can always circle the power, or that number that has x in the exponent. And the reason why I would suggest this is you can kind of see already that sometimes you'll have a number out front, and you can almost entirely ignore this number. What you're really focused on is what's in the base of that exponent. And you don't really have to worry about the number out front, because that's something that can very easily trip you up. Same thing for exponential decay. Just look at that number with the x in the exponent. You can almost completely ignore the number outside. So here, I've got 1/2 to the x. I can ignore the 1 billion out front. That's not going to change the fact that this is still exponential decay, because the number in my exponent, the base, is still smaller than 1. I can do whatever I want out front. That doesn't change that. Okay, so let's look at some examples here. We're going to look at the power, and specifically the base of this exponent. We're going to see, is this smaller or bigger than 1? Is this going to be decay or growth? So let's look at a few examples here. 0.5 is the number I'm focused on. And if that's smaller than 1, then that must be exponential decay. And in number 2, I've got 3 as my base. So I know it's exponential. I have x in an exponent. And if 3 is the base, if that's bigger than 1, then that must be exponential growth. Okay, now let's take a look at 3. Don't worry about 57, that's out front. So what I'm really focused on is the 4/7, because it's the base of my exponent. And 4/7, if you type that into a calculator, is less than 1. My numerator is smaller than the denominator. 4 is smaller than 7. So this must be exponential decay. The base is smaller than 1. And here I've got 9/5. 9 is bigger than 5, so if I type this into a calculator, I'll get 1.8 to the x, which means that that must be exponential growth. That base here is bigger than 1. Alright, I'd like you guys to pause the video here and try these last 2. So this would be exponential growth, and this would be exponential decay. Okay, and we're going to move on and talk about, y equals a times b to the x, but we're going to get a little bit more specific. Yeah, I can identify if it's growth or decay, but how much is it growing, or at what rate? So we've got 2 variables we need to worry about. A is the initial amount. That's our starting point. Maybe that's how many fish did we start with in the pond, or what was the initial amount of my loan, or how much was my car worth in the beginning. And R is going to be the rate of growth or the rate of decay. So if it's growing, hopefully like money, if I invest some money in the stock market, I want that to grow. Or decay, when I buy a car, it's going to go down in value every single year. So those are some quick examples of exponential growth or decay. The initial amount is always going to be A. It's always going to be right out front in your function. That'll be the first number you see. And the rate of growth or decay is going to be the number, inside the parentheses. What am I adding or subtracting to 1? So let's check out a few examples here. Let's look for our initial amounts first in 1 and 2. So the initial amount is the initial number you see. So 57 is the first number you see here. 1200 is the first number you see in number 2. Those are the initial amounts, the A value in these functions. And let's do the growth factor, the rate of growth, or the decay factor, the rate of decay. So we're looking at the parentheses here for our growth or decay factor. And we're saying, what am I adding or subtracting to 1? So since I'm adding here, I'm making it bigger than 1. This would be exponential growth, and my factor is 0.96 or 0.96, if you want to write it that way. Either way would be acceptable. And here I've got minus 0.2, so I'd end up with 0.8 inside if I simplified that. And since I'm making it smaller than 1, that must be decay. And my decay factor would just be 0.2. No need to put a negative. We'll specify that it's decay. So that tells me I don't really need to specify that again with a -2. All right, now let's try the middle two, and then I'll have you guys pause the video and do the last two. So the initial amounts, again, are those initial numbers that you're seeing here. And our rate of growth, our growth factors, or our decay factor, depending if I'm adding or subtracting, is going to be inside the parentheses, that number with 1. So what am I doing to 1? In number 3, I'm adding. I'm going to make it bigger. So this will be exponential growth. And in number 4, I'm still adding. So I'm still doing exponential growth. But what's my rate of growth? What's my growth factor in each problem? Well, that's just going to be the number with 1. What's inside that parentheses here? So we've got 0.67 as my growth factor here, and we got James Bond 007 as my growth factor in number 4. So why don't you guys pause the video, try 5 and 6, and then we will be done for today. So initial amounts, again, are those first numbers you see. And here I'm adding to 1. So that's going to be growth. And in number 6, still adding to 1. So that's also going to be growth. And the growth factors will be 1.4 and 0.025. Okay.